last lecture we discussed about Lorentz force. Lorentz force, right? So it is the force what combining of electric field and what magnetic field. Right? We discussed yesterday, right? In our today's class, we will discuss about velocity selector. Velocity selector. Velocity selector. Right. So here we are going to consider mutually perpendicular electric field and magnetic field. Electric field and magnetic field, or we can also say here cross field. Cross field we have mentioned, right? So the force on charged particle here, the force on charged particle, right? When it moves perpendicularly to both electric field and magnetic field right? See here what happens. We are going to consider what mutually perpendicular. I am going to take like this. Right? So this is x, this is y, this is z. So mutually perpendicular electric field and magnetic field. So this is what electric field, right? In this direction. So now in this direction, like this. This is the magnetic field. This is the magnetic field. How to consider like this. So here, this is the direction of. This is the direction of E. This is the direction of E. So here in this direction there is E. In this direction what? There is D. So then here what happens? So this is what F to be. Force of magnetic field. If we are going to consider unit vectors, this is I cap, this is J cap, this is K cap. Why? Because we are going to consider here cross fields. We are going to consider what? Cross fields. We consider cross fields consider right? Right? Cross fields we consider, right? Here this is the electric field. Right. So now this is the electric field. See, consider mutually perpendicular electric field and magnetic field. Right. So consider mutually perpendicular. This is electric field. This is magnetic field. Right. So already mutually perpendicular coordinate axis. The force on charged particle. It moves perpendicular to both the electric field and magnetic field. ಅದು ಹೆಂಗೆ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ both perpendicular right ಎರಡಕ್ಕೂ electric field ಮತ್ತು magnetic field ಗೆ ಎರಡಕ್ಕೂ ಹೆಂಗೆ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದ್ರೆ perpendicularly it will move right. When it will perpendicularly moves, what happens here? F is equal to, so we know already here Q is equal to E, right, plus V cross B, we know. So then if we are going to write once again QE plus what? Q V cross B. Calculation for this time right. So ಈ ರೀತಿ ಆಗ್ತಿದೆ right. So here one force is FE, another force is FB. So one force is experiences by the electric field, another force is experiences by the magnetic field due to the motion of a charge or moving of a charge, right. ಇದು ಗೊತ್ತಿರಬೇಕು, very important. So ನನಗೆ ಯಾವಾಗಲೂ ಗೊತ್ತಿದೆ x axis का i cap, y axis का j cap, z axis का k cap, right. So now cross product na ನಾವು ಏನು ಮಾಡಬೇಕಾಗುತ್ತೆ, ಡಿಸ್ಕಸ್ ಮಾಡಬೇಕಾಗುತ್ತೆ really, right. So here if I am going to write, right, see here FE is equal to can I write QE? ಏನು ಬರಿಬಹುದು, QE ಅಂತ ಮೆನ್ಷನ್ ಮಾಡಬಹುದು. So here QE ಅಂತಂದ್ರೆ ಬರುತ್ತೆ ಅಂತಂದ್ರೆ, so this is the force of electric field, the force of electric field. This is the force of electric field in the direction of right, which axis? Our axis is y axis, the direction of what? Y axis. Or I am going to electric field and electric field. So force of electric field in the direction of electric field, right. So then next one here FB. So what? Q V cross B, right. The force of magnetic field, in the direction of perpendicular, perpendicular to the magnetic field, and velocity, right. So here notice FE button. What is FE here? FE is in the direction of electric field. FE is in the direction of what? Electric field. Here what is another one thing is there, that is FB is also there. FB means what here? The force of magnetic field, that is also in the direction of magnetic field, right. The force of magnetic field in the direction of perpendicular to the magnetic field, and velocity, right. So here to this one I am going to write, therefore here I am going to write E is equal to QE. F E is equal to QE J cap along y-axis. Right? So the y-axis is positive and positive variable along positive y-axis. Ignore ಇದು FE right? FE ಇದು in case ನಾವು ಇದು ಈ ರೀತಿ ಐತ್ರಿ x ಅಂದ್ರ ಇದು ಈ ಪಾಸಿಟಿವ್ ಇತ್ತಂದ್ರ ಇದು ನೆಗೆಟಿವ್ ಇದು ಏನೈತ್ರಿ y ಇದು ತಗೊಂಡ್ರೆ y ನೆಗೆಟಿವ್ ರೈಟ್ ಇಲ್ಲೇ FE ತಗೊಂಡಿದ್ರಲ್ಲ FE along j cap ಬರಿಬೇಕಂದ್ರೆ ಬಂದ್ರೆ j cap along y axis y axis line along y axis which type of y axis positive y axis right positive y axis right so then FB is equal to QV cross B right so here I'm going to write FB is equal to Q so here this is I cap K cap not ಒಂದಕ್ಕೊಂದು ಹೇಗೆ ಮಾಡ್ತಾರೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅಂತ ಹೇಳಿ ಒಂದಕ್ಕೊಂದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅದಾವ ಅಂತಂದ್ರೆ ಸೊ ಹಿಯರ್ V ಕ್ರಾಸ್ B ಐತಿ V ಕ್ರಾಸ್ B ನ ಏನಂತ ತಗೋತೀನ್ರಿ I ಕ್ರಾಸ್ K ಅಂತ ತಗೋತೀನಿ ಯಾಕೆ I ಕ್ರಾಸ್ ಅಂದ್ರೆ I ಕ್ರಾಸ್ K perpendicular right I cross K ಅಂದ್ರೆ it becomes what J so ನೋಡ್ರಿ clockwise direction I cross K ಅಂದ್ರೆ ಏನಾಗ್ತದೆ I cross K is equal to minus J cross right so minus J cross ಅಂತ ನಾವು ಬರೀಬೋದ್ರಿ once again I am going to write here so what FB is equal to Q VB what I cross K once again FB is equal to Q VB I cross K means minus J cap right so idu ಗೊತ್ತಿರಬೇಕು so along negative y-axis right so j cap ಅಂದ್ರೆ ಇದು j cap ಐತೆ minus j cap ಅಂದ್ರೆ ಇದು opposite right now here these two forces FE and FB are opposite to each other ಹೌದ್ರಿ ನೋಡ್ರಿ ಇಲ್ಲಿ ನಮಗೆ QE ಐತ್ರಿ ಮೈನಸ್ ಇದು ಸಾರಿ ಪ್ಲಸ್ J cap ಐತ್ರಿ ರೈಟ್ ರೀ along ಏನ್ರಿ y axis right plus positive axis ಇಲ್ಲಿ QVB ಐತ್ರಿ minus J cap ಐತ್ರಿ along ಏನ್ರಿ minus y axis ಐತ್ರಿ minus y axis so then equal and opposite opposite to each other ಅಂತ ಹೇಳ್ಬೋದು ಏನಂತ ಹೇಳ್ಬೋದು opposite to each other ಎರಡು ಫೋರ್ಸ್ ಏನಾದ್ರು ಇಲ್ಲಿ opposite to each other right so if the values of E and B are adjusted so ನಾವು ಏನು ಮಾಡ್ಕೊತೀವಿ ಇಲ್ಲಿ adjusted right so that the magnitudes forces of forces are equal. The net force is 0. The net force is what? 0. And the charged particle moves in a straight line. So ಅವಾಗ ಏನಾಗ್ತದೆ? ಫೋರ್ಸಸ್ 0 ಆಯ್ತಂದ್ರೆ ಚಾರ್ಜ್ ಪಾರ್ಟಿಕಲ್ ಏನು ಮಾಡ್ತೈತಿ? ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಒಳಗೆ ಮೂವ್ ಆಗ್ತೈತಿ. ಸ್ಟ್ರೇಟ್ ಲೈನ್ without any change in direction. Right. So then what the equation becomes? Here automatically the equation becomes QE is equal to QVB. QE is equal to what? QE is equal to QVB. Right. So then here this Q cancel. So E is equal to what? VB. So what we have to what? Velocity is vector V is equal to E divided by V. V is equal to what happens here? E divided by V. Right. So this is the thing. Velocity selector. When we are going to consider those two forces perpendicular to each other, which type of perpendicular? Mutually perpendicular is there. So that system is only what? Mutually perpendicular is that. Right? So that's what velocity becomes here E divided by V. Right? So this condition is used to select charged particles of particular velocity in a beam containing charged particles moving with different speeds. So ಯಾವಾಗಲ moving with different speeds ಅಂತಾಗ ಈ ಕಂಡೀಷನ್ ನಾವು ಏನು ಮಾಡ್ತೀವಿ? ಯೂಸ್ ಮಾಡ್ತೀವಿ. When that is means charged particle of particular velocity in a beam of scattering. Right? So this is the thing. So this is velocity selector. Right? QVB. So V is equal to E by V. So after this one, we will discuss motion of a charged particle. Motion of a charged particle in an external magnetic field. External magnetic field. Right? So there are three cases. Now we are going to discuss one by one. Case number one. So when the particle moves, when the particle moves parallel, right? So theta is equal to 0 degree. Right? So here, this is the direction of electric field. This is the direction of what? Electric field. See, if the particle is also moving in this direction, if the particle is also moving in this direction, so particle in the direction of move ಆಗ್ತಿತ್ತು ಅಂತಂದ್ರೆ, so here the angle between V and B is equal to how much degree? 0 degree. ಯಾವುದೇ angle ಏನಾಗಲ್ಲ ಕ್ರಿಯೇಟ್ ಆಗಲ್ಲ. So that's why what, both are parallel. Both are what? Parallel. So if those are in parallel, so the angle between those two becomes is how much? Right. So then force on the charged particle. The charged particle. F is equal to what? QVB sin theta. QVB sin theta. So F is equal to QVB sin 0 degree. Sin 0 degree. So F is equal to 0. F is equal to 0 because sin 0 is 0. Sin 0 is what? 0. Got that way, right? Second case. Right? When the particle moves anti-parallel. So how much? Theta is equal to 180 degree. It becomes 180 degree. It becomes C. So this is the direction of whatever it is. This is the direction of magnetic field. This is the direction of magnetic field. So then the charge moving in this direction. So anti-parallel becomes agade one the same direction idu ee anti-parallel idu ee kade. So the angle between those two becomes how much degree? 180 degree. So then here theta is equal to 180 degree. So then the force on the charged particle, the force on the charged particle, so then F is equal to QVB sin theta. So then F is equal to QVB sin 180 degree. So F is equal to 0. So once again what? F is equal to 0 here. Or the force is minimum also. Right. So here the particle experiences in these two cases, the particle experiences zero force and it moves undeviated from its path. So ಏನಿದೆ force 0 ಇದೆ. So force 0 ಇದ್ದಾಗ it moves undeviated. So deviate ಇರೋದಿಲ್ಲ, undeviate ಆಗಿ ಏನು ಮಾಡಿರುತ್ತೆ ಅದು ತನ್ನ path ನಲ್ಲಿ ಏನು ಮಾಡ್ತೈತೆ ಮೂವ್ ಆಗ್ತದೆ. Right? So this is the first case when the motion of charged particle in an external field. Case number 1, when the particle moves parallel. Case number 2, when the particle moves in anti-parallel. Right? So now second. Third. So here the third case, when the particle moves, case third, when the particle moves perpendicular to the magnetic field. Perpendicular to the magnetic field. That theta is equal to, perpendicular means what? 90 degrees. Perpendicular means what? 90 degrees. Right. So here the force on charged particle. So directly write the force on charged particle. Force on charged particle. F is equal to, right, Q or B Q V sin theta, right? So then B Q V sin 90 degrees. So it becomes sin 90 is equal to how much? 1. So B Q V, F is how much? B Q E. So the charge, the force on charged particle is how much? B Q V. So call equation number 1. Call equation number 1. This is correct equation number 1. Correct. Right. So here, since F is Q, right? V cross B. The force will be perpendicular to V and B. So ಈ ಫೋರ್ಸ್ ಏನಾಗಿದೆ ಅಂದ್ರೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರ್ತೈತಿ ಎದಕ್ಕೆ V cross B ಏನಾಗಿರ್ತೈತಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿರ್ತೈತಿ. So when it is perpendicular to V and B, so then this force acts as a centripetal force. So this force acts as a centripetal force and it moves in a circular path. So how that is move in the circular path? See here, right? So cross in a circle. Which type of magnetic field? Cross in a circle. Which type of magnetic field? That is inward. Right? See here, this is the force, this is the what? Velocity. This is the force and what? Velocity. Or magnetic field is also there. Right? So then this force acts as a centripetal force. How the centripetal force? ನೀವು ಎಷ್ಟು ಒಳಗೆ ಹೋಗ್ತಾ ಮಾಡಿದ್ರೆ ಒಳಗೆ ಜಗುತ್ತೆ. Right? Calculate now the centripetal force. In the first we will discuss, right? So this force acts as a centripetal force. It moves in a what? Which type of path? Circular path. Anta path ಒಳಗೆ move ಮಾಡ್ತಿದ್ರೆ circular path ಒಳಗೆ move ಮಾಡ್ತಿದೆ. So circular path ಒಳಗೆ move ಮಾಡ್ತೈತಿ ಅಂತಂದ್ರೆ what is our centripetal force here? So here our centripetal force, right? So Fc is equal to mv square by r. Fc is equal to what? mv square by r, right? So there is a radius is also there. So then this force and this force, number 1 and the centripetal force is what? Becomes equal. So then I am going to call equation number 2, comparing 1 and 2. What? mv square divided by r is equal to what? QVB. So then I'm going to take, so this one is this one got cancelled. So then here is equal to R. Is equal to mv divided by what? qb divided by R. Right. So this relation we found out here. This relation we found out here. This is the radius. This is the radius. This is given by. So this is the second case. Sorry, third case where the particles moves perpendicular to the magnetic field. Moves perpendicular to the what? Magnetic field. Right. So here the time period of the particle. Time period of the particle. I am going to discuss it. Time period of particle is T is equal to 2 pi r divided by 2 pi r divided by v. 2 pi r divided by v. So then how to what? Putting the value of r here. 2 pi. What is our r? mv divided by qb. mv divided by qb into v. So this v get cancelled. So it becomes 2 pi m divided by qb. 2 pi m divided by qb. So this is the what? Time period of the particle. Time period of the particle. Right. So then the frequency of the particles. The frequency. So this is number, or we can start. The frequency of particle. F is equal to 1 divided by T. F is equal to 1 divided by T. We know already. F is equal to 1 divided by T. Right. So here 1 divided by T means reciprocal of this one. I am going to write directly here. QB divided by 2 pi r. QB divided by 2 pi r. So this is the what? This is the what? Our frequency. Frequency, right? So then our third one, angular frequency. The angular frequency of particle. So that is angular is omega. Omega is equal to 2 pi f. 2 pi f. So 2 pi, that is our f. qb divided by 2 pi m. qb divided by 2 pi m. This 2 pi m cancel, right? So qb divided by m is what? Our angular frequency. So this is the time period of the particle. Why? Because these coming are all means here the path is circular path. If the path is circular, what? We have to find out time period, we have to find out frequency, right? So we have to find out angular frequency. So that's why we discussed these three. That's why we discussed. We found